Alright, so the statement reads, two long, straight wires carrying opposite uniform line charges plus or minus lambda are situated on either side of a long conducting cylinder. The cylinder, which carries no net charge, has radius r, and the wires are a distance a from the axis. Find the potential. So with the goal of finding the potential for this configuration, it should be noted that the line charges are placed on the outside of the cylinder. And this is a conducting cylinder, which means that we can use the method of images. The method of images would allow us to put two image charges on the inside of the cylinder of equal magnitude and opposite sign to make sure that we have the same no net charge. And from there, we can modify a result we found back in Chapter 2, which was the potential of two wires, and apply it to this configuration. Alright, so the previous result was for a two-wire system and not a four-wire system. This means that we can add two two-wire systems together via superposition in order to find a potential. To do this, though, the separation distances must be in their square form. This can be done through some algebraic manipulation. First, multiply the numerator and denominator by a factor of 2, and then use the power rule for logs to bring the square from the numerator into the argument of the function. Then add two of these together for the four charges in the configuration and algebraically combine them, which we do here. Note that when we substitute in what the separation distances are from the diagram, that we're left with a bunch of parameters that were defined back in the Chapter 2 problem. We can modify these parameters for our current situation, which is seen here. A goes to a minus b over 2, and y naught goes to b plus a minus b over 2, which simplifies to a plus b over 2. Then we use the square relation between a, y naught, and r, and find that after subbing in and algebraically solving, we end up with b equals r squared over 2. This then leads us to what all these parameters are. Now that we have all the parameters clearly defined, let's note that y and z are sine and cosine, and we could combine those square terms together to apply the Pythagorean identity and save us time later. So that's what we did in our first step. In our second step, we applied via direct substitution what all these parameters are. Then we simplify down and combine and simplify until the expressions are nice. Note that in the second set we have r squares and r to the fourth over a squared, things like that. That we will factor out in the next step. So you see in the reds, what we factor out a common factor in the numerator and denominator, so we cancel them. But we had to do a little bit of algebraic manipulation to factor them, which is seen in the blue. After that, we end up with the result we knew to be expected based on the text.